Next, we have another algae project called CIRCALGAE. And Amparo Jimenez Quero from Royal Institute of Technology in Sweden is going to present. She holds a doctor in biotechnology and focuses on the valorization of biomass into chemicals, materials, and food and cosmetic additives. Yes.
Thank you very much. Thank you for the introduction, and it's a pleasure to be here today. Also seeing the wonderful results that have been achieved by the ProFuture project. Hopefully, us, in some years, we will be presenting our results. So let me first introduce the project, CIRCALGAE. CIRCALGAE is a circular valorization of industrial algae waste streams into high-value products to foster future sustainable blue biorefineries in Europe. I'm still surprised that the Commission found this project with these long names. Anyway, so what we are aiming in CIRCALGAE is something that has been discussed a little bit this morning, is how we make food ingredients a bit more sustainable and also maybe economically feasible here in Europe. So our idea is to integrate this biomass valorization of industrial relevant macro and microalgae, that's why I'm here now, waste stream into food, feed and cosmetic ingredients. Meaning we will make a holistic approach in order to get the most from this biomass. I will give you examples from macroalgae, just to talk about a different type of algae. We produce, together macro and microalgae, almost 40 million tons of biomass worldwide. However, there is a specific production of algae. I will talk about agar. I mean, most of us, we have used this molecule, right? At the kitchen or in the lab. Agar is a molecule with a very specific molecular weight and structure that is obtained from red macroalgae. This macroalgae, seaweed, we need to import it from the tropics. So it's not even produced in Europe. And you know how much agar represents from the whole biomass of this red algae? It's just 30%. Meaning we bring that with all the CO2 impact that suppose, and then we just obtain 30% of it, and the rest is discarded. In most, or like a likely scenario, is going into the soil again, but in some cases it's just burned. This biomass is highly rich in other molecules, and this is where CIRCALGAE is trying to make their work. So we are aiming to develop, three different biorefinery schemes in a upscale process. So we are going from hundreds of kilograms of biomass, and we are creating 12 different demonstrators by the end of the project. So the idea is like 2 final products will include also consumer assessment and be qualified for the market. So we are really trying to reach from the research point of view until the market. Something that has been discussed many times today about the stocks, etc., is like how fast is growing the industry of algae in Europe. And that is because there is an interest. Has been highlighted just before, like the market and the business is there. We just need to provide the ingredients, to provide what the algae can give us. So it's quite impressive how that is growing. So what we are expecting from the future blue bioeconomy is more products into the colloid industry, of course proteins, as the niche that is gathering us here today, but also fiber, very important for food and for feed applications, other nutrients as well, bioactive compounds, that is where also cosmetics and biomedical are really interested into algae nowadays, and of course energy. So here you have a schematic overview of what we do in CIRCALGAE. So the main idea is to use this side stream waste in order to extract the maximum of it. The idea that what we are implementing is an innovative cascade extraction. Some people has asked, I think, to Ima this morning, why you didn't use high pressure homogenization. That is one of the technologies that we are tackling with CIRCALGAE, together with other alternative extraction techniques that they are using just water. So the idea is to really prevent the degradation of the bioactive compounds that they are in the biomass. With that, we are assessing different algae ingredients and characterizing the functional and the bioactive properties. That is very important because the idea is not just upscale something and create a biorefinery. It's to really make something that the stakeholders has an interest. And that has been planned from the beginning in the proposal, but now with the project, a stakeholder has a main role in order to tell us, in my case, coming from a university, where to drive my research, but also in the people that they are processing algae in Europe, what they want, what type of ingredient are they interested in. And the final, let's say, real products that we will be testing are a bunch of different approaches, so for feed, food, and also cosmetic, that of course will be assessed in the term of the health benefits and also in the terms of sustainability, for instance. Here is a representation of who we are. So me, I'm representing in that case KTH, which is the coordinator of the CIRCALGAE project, but we are in total 21 different partners. You can see a couple of partners that have been also participating in Profutur. Our project has a length of 4 years, and we started in last October, meaning we still have some time in front of us in order to reach our goals. We have an estimate budget of more than 10 million euros in order to reach all these objectives that we have. And we are very proud to see like it's really industrially oriented. So 15 of these partners are industrial partners. And we are also very diverse in the background and in the location. We are coming from 11 different European countries. So let's focus in that case in this part, which is the microalgae. No? We were talking microalgae can be refined. We can do a biorefinery out of it, and that is something that is already in the macroalgae business. Some people cultivate microalgae for the pigments, for the lipids, for the proteins in that case, but there is still leftovers biomass that is very important to tackle. So once that we have separate, for example, the soluble proteins, or we have separate lipids and pigments, there is still a solid effluent. We have a lot of unextracted proteins, fiber and pigments that we claim with our novel cascade extractions can be obtained as an ingredient. So that is the high point of why we need to valorize also biomass, or this waste that is, of course, not a waste, it's never a waste, part of the biomass. It's the same case also when we use brown algae and red algae, as I presented before. So just to finish, and as a main take-home message, CIRCALGAE project is a set of cross-sectorial and systemic innovative strategies that aim to create a sustainable and competitive algae biorefinery by fully utilizing the biomass into high-value, healthy and functional ingredients. Of course, I invite you, if you want to know a little bit more about the project, like you can visit our main webpage, but we also are in different social media. And of course, and today has been clear, there is a lot of synergies to explore here, a lot of products or ingredients that can be tested by different stakeholders, and that will be great if we can find a way to integrate the end of this Profutur project with this continuation of the CIRCALGAE. Thank you very much.
Are there any questions for Amparo? Mm-hmm. Other questions?
Thank you. I forgot to tell to your community, which is a scientific community, that actually my work is I'm organizing a pan-European and Mediterranean political movement according to Aristotle, a regional movement, which is based in 3 pillars: in direct democracy, citizens' assemblies, in science, is the second pillar, like you, and in ecology and arts. So from this section of the scientific group of ours, I'm here, and there are, of course, a lot of questions about the pH en anglais, pH of français, because all this you are doing, when you say waste, what do you mean? Because the algae, as we know, it depends from the pH of the environment they are being developed. So the wastes, what kind of pH they have, and what exactly do you mean by waste? So and how you make this actually beneficial for our use as humans. Thank you.
So, as I say in the presentation, we use the name waste when we present the proposal. I'm not a fan of calling any kind of biomass waste, because in fact, and now it's very important, like we change our mindset to that. Circular valorization of any kind of biomass, meaning no waste, make it. When we mean waste is this side stream biomass that is discarded in a way. So if there is a producer of agar, in that case, and they focus just to get the molecule they want, is all the rest of the algae that they are not using. In the case of macroalgae, there is also an important fraction of proteins that they are not exploited in that waste. Also cellulose, which can be a very interesting ingredient as texturizer for food and for cosmetic application, or even use as a fiber itself. So it's not waste, it's just a side stream from the current industrial production, I would say.
On this question of a name, we speak about co-product or co-products. Then there is no question of waste, especially because waste then has regulatory issues. So even like when we want to use carbon dioxide from industries, well, it's gonna not be a waste. Could you be more precise or give example, please, on what type of products you are targeting from the co-products you will be using as a raw material?
I mean, we have, of course, a very diverse number of raw material that we are starting with. Some of the industry, they are generating not just the solid waste, but also some liquid effluents. In the liquid effluents, for instance, there are very interesting bioactive oligomers that could be used as ingredients because they have prebiotics properties. So meaning as food or feed ingredients. There is proteins, soluble proteins that they are not tackled sometimes when you just want to separate long polymeric fractions, and that is part of the liquid effluents. In the solid, I say before, there is also sulfatate polysaccharides that they are very interesting for the formulation of different final products. Also cellulose, for instance, since we are aiming to do a cascade, the important part of it is like we are extracting from the most valuable to the less valuable compounds, meaning we will put focus in implementing technologies that allow the extraction and the solubilization of high bioactive compounds, which normally have a higher price in the market. And then we will continue with harsher technologies in order to get the more recalcitrant. Once that you continue extracting, at the end what you get is the most pure fiber. So that will be, for instance, cellulose or a very recalcitrant polysaccharide that can be attached there. So that are some of the examples of the products, and of course that will be implemented in different demonstrators.
Do you receive your biomass from industry, or do you start with the most optimal seaweed you have from harvesting?
No, everything is coming from industrial side stream. That's why it's very important, like we have contact the main producers of algae ingredients in Europe.
And,
yeah.
And how is the status or condition you have? And do they keep into mind that there is a cascading that like they don't use certain solvents that is determined for the rest of your cascade?
So it's very important. This point is a very good question. It's very is essential, in fact, to understand from where this side stream is coming. So we know well what is the procedure the industrial partners they are implementing into the biomass, meaning if they have been using some harsh solvents that later on they will have some problems in order to use ingredients for food or feed, for instance, we will avoid to put it into the cascade to obtain the small molecules that probably will be affected by the use of solvent. So we will go for more harsh extraction, so we will get fibers that they are stronger, a bit less affected, and of course there is also a downstream process that need to be down there. In other cases, most of these soluble polysaccharides that they are obtained from macroalgae, they are obtained with mild extractions. So they do a maceration or something like that. So in some cases, they don't even use solvent. They just heat it a little bit and then they obtain it, meaning this waste is just biomass. It's just a raw material that can go to another biorefinery path. Yeah. No, we don't pay. We have partners in the consortium. So they got even money, so no. It's okay.
Yeah. Thank you very much. Thank you. Okay. Go ahead. You can.
Yeah, I was just wondering, we talked about our co-product, and you also said that you have some microalgae partners that provide co-products.
Yes.
Do you have an example, or you want to give us more details?
I mean, our partner is for the microalgae are from Portugal, so Algae for Future. They are providing different species that they are also refining there, so we are getting also waste. Roquette, that is not more Roquette, Klotze, that they are also providing some of the microalgae, and EGB also in Germany. In that case, they are cultivating new species that they are a bit less trendy, let's say, but we want to explore the use for biorefinery. So the biomass is a bit more diverse. They are not just cultivated for having 60% of protein. They are biomasses that we know will fit better in our cascade. So we want to really see that. And one of the points of the project is also to increase the yield of the biomass for the biorefinery process. So we are also having a study on that. But that, I mean, we are not working with the spirulina, I have to say. So this is not.
But so can you say if most of the residue you get from microalgae are, let's say, microalgae were biomasses where they already extracted, for example, oil?
Yes.
Yeah.
So that is one of the points. So, I mean, when they cultivate it for the obtention of fatty acids, for instance, because they want to sell pure omega-3 or whatever they produce, what we get is a residue that is high in proteins, but also in fiber. Because it's something that we are forgetting, but in the cell wall of different microalgae, there is a big part of fibers that is also very interesting in order to use as food ingredient, for instance. Okay, thank you.